Hello, everyone, and welcome again to your channel, Math Made Easy. Today, I want to go over a topic that should be easy. It's about um, partial fractions, but I want to see how we are going to use that in integration. So when you get an integration as a rational function, so I want to just refresh your memory about how we do the partial fractions to begin with. So for example, if I have some function, let's call it f of x, and my denominator can be factored, say, in x plus a times x minus b, I can break that into two simpler functions or two simpler fractions. I can say, for example, f1 of x, whatever this number, it may be a constant, maybe a function, over x plus a, and another function, f2 of x, over x minus b, for example. Okay? If I have a function over x squared or x plus a quantity square, I break that into two fractions. One of them is over x plus a, and the other one over. So I'm sorry, I wrote I wrote f1 of x. That's basically a constant. So I know I'm not going to use lowercase, so I would say a over that and b over that. Here also, it's going to be uh, a over x plus a plus b over x plus a square. And if it's a cube, I add a third one over x plus a cube, and so on and so forth. If I have f of x over, and this guy is, for example, x squared plus a squared. Notice that x squared plus a squared, you cannot factor it unless you use imaginary numbers. So in this case, we divide it over ax plus b over x squared plus a squared. So you make it, and if that's a square, so let's even make that a square. So plus cx plus d over x squared plus a squared quantity square. So that's basically the way we are going to use. So let's take some cases so we cover all the bases. If I have an integral, let's say I want to integrate, let's say any linear function, and then the denominator, I want to make it a quadratic that is that I can factor. So x squared minus 3x minus 18, for example, 3 times 6, or I can make it something else. Okay, dx. How would I integrate that? It's really not easy. Even if you take 2x by itself and then the 9 by itself, yes, you can use tables, but it's much easier if you use partial fractions. So the way we are going to do it is, first of all, I'm going to take that 2x plus 9 over x squared minus 3x minus 18. And I'm going to factor the denominator. You know that you want two numbers that multiply to negative 18 and add up to negative 3. So you know it's 3 and 6. 3 times 6 is 18, and 3 minus 6. So I would say x plus 3 and x minus 6. Why minus? Because that's a negative, meaning the larger of the two numbers should be the negative one. If that was a plus, I would use negative and positive. Anyway, so this looks like the first case. So I'm going to say this would be decomposed as a over x plus 3 and b over x minus 6. Usually when it's linear like that, there is a method that probably most of you heard of it, is that you say, okay, what makes this denominator 0 if x is -3, right? So you hide it because you cannot divide by 0 and substitute x equals -3 in the others. So if x is -3, that would be -6 plus 9, which is +3. And -3 minus 6 is -9. So a equals -1/3, 3/9. It's that simple. And then to do it for this x equals 6, you want to find what's b. You make x equals 6 and hide that. If x is 6, then 12 plus 9 is 21, and 6 plus 3 is 9. 21/9 can be simplified as 7/3. So that's it. It's very easy when it's linear. If you don't want to do that, then you can take a common denominator, which is x plus 3 times x minus 6. And then this would be a times x minus 6 plus b times x plus 3, right? And that should equal to x plus 9. So now we are going to write two equations in two unknowns. How? First, you distribute the a and the b and forget about the denominator because it's the same denominator. So we are going to equate the numerators to the numerators. First, let's take the coefficient of x. I have ax plus bx. So a plus b x. And then I have -6a plus 3b. So plus, I can factor a 3. Okay, say it's plus 3 times b minus 2a. Right? Do you see that? -6a, -6a, plus 3b, plus 3b. And that equals the original 2x plus 9. In order for those two to be equal, then a plus b should equal 2. The coefficient of x's should be the same. And -6a plus 3b should equal 9. In fact, I can simplify that by simplifying by 3, and I can say -2a plus b equals 3. If I subtract the bottom from the top, I will get a minus 2a is 3a, and b minus b is 0 equals 2 minus 3 is -1. Divide both sides by 3, you get a equals -1/3. Exactly like we found here. Substituting here, if a is -1/3 plus b equals 2, which is 6/3, then I will add 1/3 to both sides, and I get b equals 7/3. So I get the same results. Now it becomes an easy integral. Okay, so this integral would become two integrals. The first one has a equals -1/3, so I can write -1/3 dx over x plus 3 plus 7/3 the integral of dx over x minus 6. You know, the integral of that is the natural log of the base, so you get -1/3 natural log of the absolute value. Notice if x can be negative, if x is -3 or less, this will not work, so you have to take the absolute value of x plus 3. Same thing here, the natural log of the absolute value of x minus 6, because if x is 6 or less, that will not be working. And of course, don't ever forget the constant, because that's a function, right? It's not a definite integral. And that's the answer. Again, some people would say, oh, can I take the -1/3 and make an exponent for this? So I divide by the cube root of that. Yes, you can. Same thing here. You can say natural log of x minus absolute value of x minus 7 raised to the power of 7/3. But that's basically how we do it. So that's a pretty straightforward one, and it's application of the first case. Let's move to one that is more involved. So for example, if I say integrate a function, and let's make this function the numerator, we can make it let's make it a higher power. That would be better. 2x to the 4 minus 12, and I divide that by x cubed. And when I factor this, so plus 4x. Okay? In that case, when the numerator degree is higher than the denominator, it's better to use long division. Okay? So if it's an improper fraction, you have to divide it. So I'm going to say 2x to the 4 minus 12 divided by x cubed plus 4x. 2x to the 4 divided by x cubed is 2x. And then I multiply, I get 2x to the 4 plus 8x squared. Subtract. These cancel, of course, and I get negative 8x squared minus 12. Since this is less than that, you stop and you say this would equal to the integral of 2x plus, in fact, minus, because both are negative. So minus in fact, I can factor even 4, right? Because 8 and 12. So minus 4, 2x squared plus 3 over x cubed plus 4x dx. This one is easy. I integrate it as x squared. So let's look, and the negative 4 is a constant. So let's see how we break down 2x squared plus 3 over x cubed plus 4x. I can see that the denominator, I can factor out an x. So 2x squared plus 3 over x times x squared plus 4, which is the sum of two squares, which cannot be, would be x plus 2i times x minus 2i. So it's not a real number, right? So I will have to break that into two pieces. Notice the first piece is similar to x plus a, where a is 0. So it's just a over x. But the second one, remember, it's the third case down here. You have to write it as ax plus b over that. So in that case, we write it bx plus c, because the a is already used. We know that these may not be the same numbers, so we cannot use a again. X squared plus 4. Now we cannot use the hidden method because I have a square and stuff, but but you can use it for the x. Anyway, so I'm going to say, if I use a common denominator, which is x times x squared plus 4, I will get ax squared plus 4a plus bx squared plus cx. So when I arrange them, the coefficient of x squared, the coefficient of x, and the constant, they would look like that. A plus b x squared plus cx plus 4a over that equal this over that. So that should equal 2x squared plus 3. I can see right there that c equals 0 because I don't have a term in x. So c equals 0, meaning that there won't be any c. I see that 4a equals 3, right? 4a equals 3. So a equals 3/4. Notice I could have found that using the hidden method. I say, what makes the x 0? 0. So I hide it and replace x equals 0. So the numerator would be 3, the denominator would be 4, and I would have gotten the 3/4. That's why I said, yeah, I can find it for a, but I cannot find it for the bx plus c. We already found that c equals 0, so now I say a plus b equals 2. But since a equals 3/4 and 2 is 8/4, then b is 5/4. So that when I add them up, I get 2. So now I can go back to the original problem and say it's the integral of 2x minus 4 times. Notice instead of 2x squared, I wrote it, we already found a is 3/4. So this would be multiplied by 3 over 4x, 3/4 over x, plus 5/4 x, 5x over 4 times x squared plus 4 dx. So I broke this thing into 3 over 4x and 5x over 4 times x squared. I have a 4 out, so I can get rid of the 4s. Okay, now let's do it. The integral of 2x is x squared. The integral of negative 3 over x is negative 3, the natural log of x. But what is the integral of negative 5x over x squared plus 4? Okay, dx. That's easy, but if you don't see it, what do we do? What do we usually do? We can use substitution. And then later, maybe in advanced integral, you don't need substitution. You can do it at all, as I will show you. So say let u equals x squared plus 4. Then du becomes 2x dx. Okay, this integral is negative 5x over x squared plus 4 dx. I don't want negative 5, I wanted 2 dx. So I can 2x. So this can be written as negative 5 times 2x dx over 2 times x squared plus 4. You see what I did? I just multiplied top and bottom by 2 because this guy right now is du. And this guy right down here is u. And I have negative 5/2. So the integral of that is negative 5/2. Oops. Negative 5/2 natural log of u. But u is x squared plus 4, right? So that's the negative 5/2 natural log. And instead of u, I write x squared plus 4. And I don't forget the constant. Notice I didn't use the absolute value. I could have used it, but it's irrelevant because for any real value, x squared is greater than 0. And when I add 4 to that, also, it's still greater than 0. So I don't need, I know that this number is always going to be positive, so I can take its natural log. Okay, and that's it. So basically what we did here is we took a tough integer, I had to use long division to break it down. And then I took this fraction, decomposed it into two simpler fractions, and then took this fraction and used substitution. So I did a lot of stuff, but it's really pretty straightforward. Nothing is hard. Let's take one last one. So I think the only thing we didn't cover is when I have a square, because here we had just x and then this, but we never got a case like that. So let's try to make up some numbers here. Let's say integrate. Let's make the numerator. I don't want the numerator to be larger because we already used long division. So let's pick something that, a function that may be more complicated. So maybe a degree of 3 and a degree of 4. So I can say 8x cubed, maybe minus 6x squared, plus 27x minus 18. And then I divide that by x squared times x squared plus 9. Again, so this would also be ax plus b. It's a sum of two squares. Okay? So now I know that I can take this guy, dx. I'm just going to take this fraction here and write it as a over x plus b over x squared. Notice if I have x squared, so I will take one constant over x and one constant over x squared. And as I said, if that x to the n, then I can take as many as n. So x cubed, I will have three cases, a over x, b over x squared, c over x cubed, and so on and so forth. And this guy, we already learned how to do it. It's c x plus d over x squared plus 9. Here I cannot use the covering method because I have a square. If that was an x, yeah, I can find the a. But here, which one is it? Is it a or b? I don't know. So I'm going to take a common denominator, which is x squared times x squared plus 9. This x would be multiplied by x squared. So x cubed plus 9x. So I will have ax cubed plus 9ax, right? When you multiply that by x times x squared plus 9. The b is multiplied by that. So plus bx squared plus 9b. And then this would be multiplied by x squared. So plus cx cubed plus dx squared. All of this would be the same as those. 8x cubed minus 6x squared plus 27x minus 18. So now I have 4 equations in 4 unknowns to solve for a, b, c, and d. So let's equate the x cubed coefficient. A plus c equals 8. Then I look at the x squared. I have a b and a d. So b plus d equals negative 6. Then I look at the x's. I have 9a, just 9a, right? We don't have any x's again. Yeah. So 9a equals 27. I found a is 3. And if a is 3, then c is 5. You see how easy I found these two? But b and d didn't show up. They will show up at the end when I take the coefficients of the constant. Constant here, I have only 9b. And the constant here is negative 18. So b is negative 2. If b is negative 2, then d is negative 4. So -2 minus 4 is -6. Okay? So now my integral becomes the integral of 3 over x, the b is -2, minus 2 over x squared, plus 5x minus 4 over x squared plus 9 dx. I'm going to break this also. Okay, so that would be the integral of 3 over x minus 2 over x squared plus 5x over x squared plus 9 minus 4 over x squared plus 9 dx. The first one, we already did that before, so that's the natural log 3 times the natural log of the absolute value of x, which is the natural log of x cubed. Then I have the second one. This is -2 x to the -2. When you integrate x to the -2, you get x to the -1 over -1. So the negative and the negative cancel, and you get plus 2 over x. It's as simple as that. The next one, it's almost what we did here, right? We had the 5, but it was negative, I believe, here. You had -5x over x squared plus 4. Here we have plus 5x over x squared plus 9. Again, I'm going to say let u equals x squared plus 9. So du becomes 2x dx. So I'm going to write this as 5 over 2 times 2. You see how I wrote it? The 2 and the 2 cancel, and I had 5x divided by, but why did I write it like that? Because now the numerator 2x dx without the 5, so plus the 2x dx is du. Du is 2x dx. U is x squared plus 9. And I have 5 halves. So the integral of that is 5 halves natural log of u. So I write it here as 5 halves natural log of x squared plus 9. And again, I don't need the absolute value since x squared plus 9 will always be positive. And finally, I have the integral or -4, the integral of -4 over x squared plus 9 dx. I know that the integral of dx over x squared plus 1 is the arctan. But that's not x squared plus 1, that's x squared plus 9. What do I do in a case like that? I cannot subtract 8, right? That some people I heard said subtract 8 and make it 1. No, you can't, of course. I'm just kidding. But I can do something else. Since this is a square, and the square of 9 is 3, what if I say, let's use another letter than u. So let's say let v equals 3x. So x squared plus 9. So I'm sorry, I wanted x to be 3v, right? The other way around. Let x equals 3v. So x squared plus 9 would be 9v squared plus 9, or 9 times v squared plus 1. So now, and dx equals 3 dv. So see what we are going to do. I would say this is the integral of, first of all, I have a -4, so let's have it outside. Dx is 3 dv, so times 3 dv. And the numerator is x squared plus 9, which is 9 v squared plus 9. I take the 9 out, so that would be 3 times 4 over 9, the integral of dv over v squared plus 1. Notice the 3 and the 9 would make that 3. And that would be negative 4/3 arctan of v. But v is x over 3. So I will get here minus 4/3 arctan x over 3 plus a constant. And that's the integral. It's a lot. But you see here, we were lucky. I mean, the numbers worked out so that we ended up with integer coefficients. This is easy. This is easy. And I had to break that into two fractions, 5x over that and negative 4 over that. Why? Because 5x over that, we already saw that earlier, right? It's a natural log. Instead of 5, I wanted 2 because the derivative of the denominator is 2x. And this is 5. So I can say 5 over 2 times 2. And now I can take 5/2, the natural log of the denominator. Here, I had to work something to make that an inverse tan, arctan. Okay, it's negative 4/3 arctan of x over 3. And that basically is it for today. I think we covered all the possible scenarios. Something over x plus a or minus a, something over x or x squared, and something over a sum of squares that cannot be decomposed. I hope this was an easy thing. It's just a quick review for partial fractions. Even if you are not taking calculus yet and you need help with partial fractions, you stop before the integral. It's how you find, how you write this in a simpler way, and forget about the integral. And finally, if you have any questions, as always, I encourage you to please write down any comments you have in the comments section, and I will get back to you as soon as I can. Thanks, and have a great day. Bye.